Hello everyone, myself Sai Prasad, a lecturer in Akhlabat High School and the Junior College. Welcome to a series of the lectures of Intermediate First Year Maths A. We have started our discussion with matrices. What did we learn? We have started with the basic definitions, types, and the next transpose, inverse, determinants, and we have been studying how to solve the three given equations with the three unknowns, right? In the last sessions, we learned the basic method to check whether the three equations are consistent or not. Then we learned what is Cramer's method. Hope everything is clear in Cramer's method, right? Today we are going to learn the next method, that is matrix inversion method. Okay, the first step is as it is, that is they will give three equations, we have to write it in the matrix form. How do we write? That is all coefficients together, a1, b1, c1, a2, b2, c2, a3, b3, c3 into x, y, z, that is equal to d1, d2, d3. Is it right? This is a, x, d. Right? We got three things. Then what do? I already told if ax equal to d, I can write x is equal to a inverse d. Okay, this is what my x is. Okay, did you understand? Which means first of all I have to find the a inverse, then I have to multiply it with the d. Is it clear? How do we find a inverse? A inverse is obviously my formula, adjoint a by det a. Is it right? What is adjoint a? Again the reciprocal of my cofactors matrix. Is it clear? Did you understand? Right? What is that we have to remember here? I have to know how to find this a inverse and multiply with the another matrix. Is it clear? Shall we do the problem? Let's do. Look at the question here. These are the three equations. Hope you remember these three equations, right? What is the answer? Right. The answer should be 311. Yes, we know. We know how to solve using Cramer's method. Let us learn how to solve using matrix inversion method. Okay. What is the first step? Obviously, writing in the matrix form 3, 4, 5, 2 minus 1, 8, 5 minus 2, 7 into x, y, z, that is equal to 18, 13, 20. A, x, d. Is it fine? What is the first thing I have to do? In order to find A inverse, I have to find det first. That is, determinant of A is 3, 4, 5, 2 minus 1, 8, 5 minus 2, 7. Right? How do we solve this? 3 into minus 7 plus 16 minus 4 into minus 7, minus 14, minus 14 minus, plus 14 minus 40 plus 5 into minus 5 plus 4. If I solve this, I will get it as 136, which is not at all equal to 0. Therefore, inverse exists. Right? What is the next step I have to do now? I have to find cofactor matrix. How do we do? Cofactor matrix of A. That is plus, minus, plus, minus, plus, minus, plus, minus, plus. Hope you remember that. Fine. 3 into, first I have to find this value, I have to close these both, then I have to multiply this det. Minus 7, tell me here, minus 7 plus 16, how much is it? 16 minus 7 is 9, and here 7 2s are 14, 14 minus 40 is minus 26, here minus 4 plus 5, that is plus 1, and the next 28 plus 10, 38, and the next 21 minus 25, minus 4, here minus 6 minus 20, minus 26, here 32 plus 5, that is 37, and the next 24 minus 10, that is 14, and finally minus 3 minus 8, that is minus 11. Is it right? Now what is that we have to do? Let us simplify, let us write in a simplified way. 9 minus 26, 1 minus 38 minus 4, 26, 37 minus 14 minus 11. Then what is adjoint A? Adjoint A is reciprocal of this cofactor matrix. 9 minus 38, 37 minus 26 minus 4 minus 14, 126 minus 11. Is it clear? Now what is that we have to do? Now I have to write A inverse as adjoint A by det A. Adjoint A by det A, that is equal to 1 by 136 into 9 minus 38, 37 minus 26 minus 4 minus 14, 126 minus 11. Okay, what is my formula of inverse? X is equal to A inverse into D. Therefore, X is equal to, what is my A inverse? This is my A inverse, 1 by 136 into 9 minus 38, 37 minus 26 minus 4 minus 14, 126 minus 11 into, what is D? D is my constant matrix, 18, 13, 20, 18, 13, 20. Now we have to multiply these two matrices. What do we get? Can you multiply? 9 into 18 minus 38 into 13, 37 into 20. That will be one term. Minus 26 into 18 minus 4 into 13 minus 14 into 20. Then 1 into 18, 26 into 37, 11 into 20. If you do that, you will get it as 408, 136 and 136. Is it clear? Now multiply 1 by 136 to inside. 408 by 136, 136 by 136 and again 136 by 136. This ones are, this 3s are, these both cancel 1, these both cancel 1. Answer is 3, 1, 1. Is it clear? Did you get the answer? What is that I have to know here? Here I have to know how to find A inverse first. Then finding this D, multiplying with the D and finally getting the exact answer. Here the multiplication takes a long time, just check it. Don't miss anything, whether it is a plus or minus or whatever. Okay, what's the first step we have to do? We have to look at the question, then we have to write in the matrix form Ax equal to D. Right? First of all, we have to find the determinant of this coefficient matrix. However, we'll get non-zero term, then only inverse exists. In order to find the inverse, we have to find cofactor matrix, then transpose it, then find in the, substitute in the formula of A inverse, then multiply with D. You will get the answer for X, Y, Z. Is it fine? Good. Shall we do one more problem for this? Let's do. See here the question given here it is, he is asking us to solve using matrix inversion method. What is the question given? 2x minus y plus 3z equal to 9, x plus y plus z equal to 6, x minus y plus z equal to 2. What is that we have to do? First step, we have to write it in the matrix form. Then we have to find the determinant of the coefficient matrix, and the next we have to find cofactor matrix, then adjoint, and finally we have to find A inverse, then substitute in the formula A inverse into D. These are all different steps we have to follow here. Okay. Now see here, how do we write in the matrix form? We will take the coefficients 2, minus 1, 3, 1, 1, 1, 1 minus 1, 1, right, into coefficient matrix, that is equal to 9, 6, 2. Fine. This is my coefficient matrix A, this is X and this is D. Don't get confused here. Okay. Now what is that I have to do? I have to find the determinant of this matrix, that is det A is equal to 2 minus 1, 3, 1, 1, 1, 1 minus 1, 1. Okay, plus minus plus. Fine. 2 into 1 into 1 is 1, minus to minus, again it will become plus. Here also minus to minus, plus 1, 1 minus 1, plus 3 into minus 1 minus 1. Isn't it? That is 2 into 2 plus these both will cancel. I will get 1 into 0 plus 3 into minus 2. 2 2 is 4, 3 2 is 6. Answer is minus 2, which is not equal to 0. Therefore, I know that inverse exists. What is that I have to do now? I have to find cofactor matrix. How do we find? That is cofactors of these things. Cofactor matrix of A. That is, how do we do? Plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, why do I write that? Hope you know that. This is my I into, tell me, minus 1 whole power I plus j. I is number of row and number of column into the minor. Okay, here in the first row 1 plus 1, first row first column, minus 1 power 2 is obviously 1. Here first row second column, it will become negative, minus 1 power 1 plus 2, that is 3. Therefore, this will become minus. That's in that way we will write alternative plus or minus. Okay. Now see here, what is the minor of this term? We have to close these both. I have to multiply, find the det of this small matrix. 1 plus 1, that is 2. And the next, for this matrix, 1 minus 1, that is 0. For this, minus 1 minus 2. That is minus 1 is minus 2. Did you understand? Fine. What about this term? Minus 1 plus 3, that is 2. For this term, 2 minus 3. And for this term, minus 2 plus 1, that is minus 1. And for this, minus 1 minus 3 is minus 4. And for this, 2 minus 3 is minus 1. And for here, 2 plus 1 is 3. Is it clear? Now let us write it. That will be 2, 0, minus 2, minus 2, minus 1, 1, minus 4, 1, 3. Is it okay? This is my cofactor matrix. Then what we have to find? Adjoint A, that is nothing but reciprocal of cofactor matrix of A, reciprocal of this. Is it right? Now I have to do reciprocal for this. That is 2 minus 2 minus 4, 0 minus 1, 1, minus 2, 1 and 3. Is it fine? This is my adjoint A. What about A inverse? A inverse is adjoint A by det A. What is det A? Minus 2. That is 1 by minus 2 into 2 minus 2 minus 4, 0 minus 1, 1, minus 2, 1, 3. If you want to multiply minus or 2 inside, it's okay, but it's not better if we multiply directly now itself. Is it fine? Let us find x, that is A inverse into D. Okay, x is equal to, this is A inverse, right, into what is D? D is my constant matrix, that is 9, 6, 2. 9, 6, 2. Okay, shall we multiply? Okay, see here, 2 9s are 18, 6 2s are 12, 4 2s are 8. And the next 0 into 9s are 0, minus 6 1s are 6, plus 2 1s are 2. Here minus 18, minus 6, minus 6. Okay, is it fine? Now that is equal to, how much do we get? 1 by minus 2 into 18 minus 12 is 6, 6 minus 8 is minus 2. Here 2 minus 6 is minus 4, and last here what do we get? Minus 18, minus 6, minus 6. Is it clear? Sorry, here it is plus 6 and plus 6. 6 plus 6 is 12. 12 minus 18 is minus 6. Okay. Now let us multiply this by minus 2 to inside. That will become as minus 2 by minus 2, minus 4 by minus 2 and minus 6 by minus 2. Minus minus cancel, 2 2 cancel. This will be 1, 2 1s are 2 2s are, this is 2, minus minus cancel, 2 1s are 2 3s are, this is 3. Is it right? Did you understand? Isn't it simple to do? Fine. Once again, see here. First step, remember these all things. He'll give the question. Fine. Then we have to convert it into matrix form. Then I have to find the determinant of this coefficient matrix A. Okay. Whatever the value we get, this is minus 2. Since it is not equal to 0, therefore inverse exists. Then I have to find the cofactor matrix. How do we do? First we will put all plus minus plus alternatively. We have to start with plus. Okay. Then simplify it and write as a matrix. After that, find adjoint A. Adjoint is again reciprocal of this cofactor matrix. Okay. We will get this. Then we have to find A inverse. Then substitute in x is equal to A inverse into D. If you want, you people can directly write it as 2 by minus 2 minus 2 by minus 2 and everything here itself, and then multiply it with it. Rather than doing that, just we have written as it is, then multiply with 962, we got the values. Then finally I have sent this minus 1 by 2 inside. Okay. Then I can directly get the simplified version of this. Is it clear? What did we learn in this session? Right, we learned when a given equations are 3 with the 3 unknowns. Okay, then I know how to check whether these 3 equations are consistent or not. Okay, you know how to find the rank, right? And the next we learned how to find using Cramer's method. How do we do? First we will take determinant of A, then det 1, det 2 by replacing first 2 and 3 respectively columns. Is it right? Then I will get the values of x, y, z as delta 1 by delta, delta 2 by delta and delta 3 by delta. Similarly, in matrix inversion method also we will find A inverse and multiply with the constant matrix. Is it clear? In the next session we will learn how to do this solving equations using Gauss-Jordan method. It does not have any inverse or anything, directly elementary operations. How to do and everything, we will learn them. Is it clear? Did you understand? Fine. Hope everything is clear for today. Let us meet in the next session with more problems of matrices.